Hey guys, good evening. It's Unit 9, continued, Day 2, Coordinate Geometry. And I'm going to tell you it's Monday night when I do this. And I've already had a couple of comments come in from tonight's lesson, the Day 1 lesson. And one of the comments was, well gee, this just seems like a combination of the coordinate plane and geometry. Well, in fact, that's exactly what we're doing. We're taking what we've learned about geometry so far, polygons and lines and such, and we're going to put that on the coordinate plane, and we're going to combine the two subjects, and we're going to make some connections there. So the things we're going to talk about tonight are slope of a line, which we know we've discussed that before, parallel lines and perpendicular lines. We're going to graph and classify quadrilaterals on the coordinate plane. So our four-sided polygon, we're going to put some of those on the coordinate plane by plotting their vertices. And then we're going to have a situation where we're going to find the coordinates of missing vertices of a quadrilateral. In other words, I'll give you a description of the quadrilateral and give you some points, and then we'll have to come up with the last set of points. So that's what we're going to talk about tonight. Buckle up, here we go. So I've got a coordinate plane here, and I've got a couple of lines on it. And how this is different from when we did slope last time is, last time we just say had a line, and we asked you to find the slope of that line. Well, now this time we're going to want you to find the slope of that line, but now we're going to want you to look at the whole picture and find a line that has the same slope. In other words, we're going to want you to look at one line, find the slope, and then find a line that's parallel to it. And we know if the lines are going to be parallel, then the slopes have to be equal. So as a reminder, slope is equal to the rise over the run, which is the change in y direction over the change in the x direction. So how I would do this, I would figure the slope of these lines, then I'd write the slope right next to the line. Here's line AB. And I've got a change in 1 in the y direction, change in 1 in the x direction. So I've got 1 over 1, the slope is equal to 1. So line AB, the slope equals 1. Let's look at line EM. So I've got change in 1 over change in 1. So I've got 1 over 1 again, the slope is 1. So we've got line EM has a slope of 1. Let's look at line EF. Line EF. See, that's a vertical line. That's a change in 1, 2, 3 in the y direction over no change in the x direction. So our slope is undefined. So line EF slope is undefined. Let's look at line XY. I have a change in y of 0 over a change in x of 2. So the slope is 0. M equals 0. Then we've got that line, did that one, that one. Okay, so I've got line XD next. It's another vertical line, so I just know that that's undefined. I'm just going to go ahead and write that. And then lastly, line CD. Line CD has a change of -1 over +1, so the slope of this line is equal to -1. So what we've done so far is we've taken these lines and we've figured the slope of each line. And now we want to ask, are there any parallel lines? And as a reminder, we know that parallel lines have the same slope, right? And right away I can see that line AB has a slope of 1, as does line EM. So we know that those two are parallel lines. You're probably saying right now, well, I could look at those and tell that they're parallel, but they're not always going to be so easy to see. And I'll show you that in the case of perpendicular lines. we know that perpendicular lines cross at 90 degrees, and we can see that these two lines are perpendicular to each other. But are there any other perpendicular lines on the graph? Well, if you can't just look at it, what you need to know is that perpendicular lines are lines that have slopes that are opposite reciprocal of each other. Opposite meaning the opposite sign, reciprocal meaning that it's flipped. You flip the numerator and the denominator. And as an example, let's say I have two lines. We'll call this line AE, and I'll call this line BD. So BD has a slope of -2, and AE has a slope of 1/2. And we can see that these numbers, clearly there's an opposite sign, and then they are reciprocals of one another. So, like this 1/2, we just flip it, and it becomes the 2. Okay? So, perpendicular lines are lines whose slopes are opposite reciprocals of one another. So you just change the sign and you flip it. So let's look over here. I've got line AB and EM, we know have a slope of 1, but line CD has a slope of -1. Well, that is an opposite reciprocal, right? The sign is opposite, and reciprocal of 1/1 is really just 1/1. So line CD is this guy down here. AB is up here, EM is there. So what we're saying is this line, CD, is perpendicular to these two lines. This is one of those cases I was just telling you about where it's just not too easy to see. So what I've done, where did I put that? I've taken line CD and I've extended its line up here. Then I extended the lines of AB and EM. Now it's kind of easy to see that they're perpendicular to one another. But frankly, when I started this problem, I didn't know they were going to be perpendicular because I can't tell. So even though they don't extend these lines on the graphs, you still need to find the slopes, and you need to check and see if they're perpendicular. And just to sort of verify that this is 90 degrees, I've got an index card here with a 90-degree angle on the corner. If I slide that right in there, you can see that's a 90-degree angle, as is this one right here. So if you're given a graph with all these lines on it, and you're asked to find if lines are parallel or perpendicular, you need to find the slopes of the line, and you need to find if the slopes are equal, and they won't be parallel. If the slopes are opposite reciprocals, they will be perpendicular. That's one of the things from this section. So as promised, another thing we'll need to do is graph the vertices of a quadrilateral and then identify it by all the names that apply to it. So I have some points here, and I'm going to graph them, and I'll be right back. Now would be a good time for you to stop and sketch this out in your book. Okay, so when I was gone, I plotted the points in blue, and then I connected the lines with the red marker. And so now I've got a polygon. I've got a four-sided polygon. I've got a quadrilateral. So the statement is write all the names that apply to the quadrilateral. Well, I can tell that this segment and this segment are parallel. They're both horizontal lines. And I highly suspect that this segment is parallel to this one, but I don't know for sure. So I'm very quickly going to calculate the slope here. So I go up 1, 2, 3, 4, and over 2. So up 4 and over 2. So the slope of this segment is 2. Now I go up 1, 2, 3, 4, up 4 and over 2. So the slope of this segment is also 2. So I've just proved that I have two parallel lines here. So I have one set of parallel lines and then a second set. So at the very least, I have a parallelogram here. I also have the 1, 2, 3, 4-sided figure, which means that I have the quadrilateral. I'm thinking, for a while I was thinking I had a rhombus, but this side is a little bit longer than this side is. And for this to be a rhombus, then all four of these sides would have to be congruent. So this is not a rhombus. So there you go. You'll be given some points. Plot them on the coordinate plane. Connect the points to form a polygon. And then identify the polygon according to your graph. So the last kind of problem of the night. We're given a question where it says find the coordinates of the missing vertex on a rhombus A, B, C, D. So what they're saying, guys, is we have a rhombus with vertices A, B, C, and D, and we know vertice A, B, and D, but we don't know what C is. So the first thing we're going to do is plot these points. So why don't you go ahead and do that. Points B, A, and D have been plotted on the coordinate plane, and I'm going to use the two things that I know about rhombuses to try to find out where that fourth point goes. I know that rhombus has four congruent sides. So wherever I put the point, it has to result in sides that are congruent. I also know that both sides, that a rhombus has two sets of parallel sides. So if I was to sketch in a little line segment right here, wherever I put this fourth point, somewhere around here I'm guessing, it's going to have to create another set. It's going to have to create a set of parallel lines, parallel line segments. So I need to find the slope of this so I can create a parallel line over here, using the principle that the slopes will be the same if they are parallel. So I see that I can go down 2, so negative 2 over 1 will give me the slope of segment AB. So that's a slope of negative 2. Oops, negative 2. So I'm going to start at D, and I'm going to do just what happened over here. I'm going to go down 2 and positive 1. I'm going to put a little point right there. Before I ink that in, I'm going to sketch out the polygon that would result. I have a four-sided figure, which is what I wanted. I have a set of parallel lines here and another set here. And all of these sides are the same length. That one, that one, that one, and that one. They're all the same length. So the last thing to do is find out what the ordered pair of this point is. Go ahead and ink that guy in. I'm going to call him point C, and the ordered pair is 1, positive 2, down, negative 1. So the ordered pair is 2, negative 1. And that's all you do. Follow the clues that you're given from the quadrilateral that you're given. Plot your points. Over here on the graph, plot your points, and find out where you'd have to put that last point to obey the rules of the shape that you're given.